Today, let me finish chapter 8 today. And next week, on Monday, Wednesday, Friday, we are going to review. So let me show you the Cengage homepage. Let me go to, yes. Section number 4. See, already I reopened from homework number 20, 21, 22, 23. I think the homework number 23 is due tonight, but please look at the due date. I extended until next, the Monday 2 weeks later, right? Yeah. Because we are going to take the final exam on this Monday at noon, right? Yeah. So I reopen and extend the old homeworks. It's just before the final exam on Monday noon, right? Yeah. And this is the new one, yeah, from today, but it's the same day. And already I posted the review homeworks from chapter 1 to 5. Next week, yeah, we are going to review. Yeah, we are going to discuss the review homework. And next Monday, I will post the second review homeworks from chapter 6, 7, 8. So next week, we are going to review is everything as preparing the final exam. But already I reopen and post the review homeworks. Please don't wait. It's until next weekend. Yeah, please this weekend. The statistics is not the only one for you in the final exam week. Yeah, probably the statistics will be your first final exam, but yeah, you have any other final exams in the final exam week. So please, yeah, I think already you got good scores in the previous homework. Yeah, you don't have to make them up, right? It's just to do homework number 23, 24, and this is focused on the review homeworks. When I open the review homeworks, here's another reason why. Try it this weekend, tomorrow, because it has 24, the 24 questions. Second review, maybe another 20. Yeah, from chapter 6, 7, 8, right? Yeah. So we don't have enough time. See, we have one more week next week, and we have one more exam. It will be the final, right? It's almost done. Almost done. Thank you for taking statistics the whole semester, right? But one more week, one more exam, right? Yeah. Please do more, and please do better, right? Yeah. So you can get the better score. Yeah. So it is my schedule. So any question? Is there any question next week and about the final exam? Okay. Let me finish the lecture. Now we have let me see, independent two samples. So now we compared the mean difference before from the independent two sample. Just before the section 8.5, we had dependent two sample, the paired data, right? Yeah. But now here we had independent two sample, and already we tested the mean difference, and we assume we knew the sigmas. So we got the z-score, and we found the probability from the z-table, and we made the conclusion and interpretation, right? And as you expected, today, unknown, yes, here, yeah. We are going to compare the two means again, but they are unknown. What do you expect? We are going to take the t-score. We are going to look for the range of the p-value from the t-table with the given degree of freedom. right? Yeah. So please look at this example. It is the today's topic. See, we have S1 as S2, and we have independent two groups. Let me see, what is this for? Oh, it is the pharmaceutical example to give the fast-acting relief, right? So we have two brands, this medicine for headache, and they measure the time, how long does it take? Yeah, it's the pain relief, right? And the brand A took 21.8 minutes on average. Brand B, independently, the second one, 18.9 minutes on average. Which one is better? Which one is faster? The second one, the B, is faster. How much difference? It's about only 3 minutes, right? So we want to test if the 3 minutes difference is big or small, right? So that is we want to test, right? At 5%, no difference. We are going to state H1 two-tailed, not equal to. Does it make sense? Right? Yeah. So let me state the null hypothesis is comparing two independent sample. So comparing the two means and two-tailed not equal to. And we are going to take the t-test statistic, take the mean difference, 21.8 minus 18.9, square root of 8.7 square over 12, and 7.5 square, and also 12. You know, in this example, we had independent two samples, right? They don't have to get the same sample size. You know, before, when we got the dependent sample, the paired data, paired, they must have the same sample size, but it doesn't have to be. But now, it's coincides. Yeah, in this example, it's a 12 and 12, right? But they don't have to say. But anyway, let me take the mean difference. 21.8 minus 18.9. It's almost 3 minutes. It's 2.9. And denominator is, let me take the square root of 8.7 square over 12 and 7.5 square over 12. What's this? The denominator will be 3.3159. Then let me take the fraction. It's a 2.9 over 3.3159 will be 0.875 t-score with the S's. And we have to look for the p-values from the t-table. Let me show you the t-table. Oh, before the t-table, can you give me the degree of freedom? See, we have two degree of freedoms, 11 and 11. You know, actually, we picked smaller one, but they are same sample size, same degree of freedom, so 11, right? But actually, we have to pick the smaller one. So 11, so let me open chapter 7, t-table. Yeah. How many degree of freedom? 11. One-tailed or two-tailed? Two-tailed. How much was the t-score? 0.875. 0.87. Between 25% less than 50%, or much bigger. It's a huge probability. So let me take the p-values. Must be bigger than 0.250, less than 0.50. How much was the alpha? Alpha was 5%.
Oh, yeah, definitely.
Is it bigger than 5% or less than 5%? Bigger. What will be the conclusion then? Do not reject who? HO. Thank you. Yeah. Not to reject HO. Not to reject HO. We have to interpret HO. What is said? They are same. What's the same? Time. How fast? Same. Even there is a difference, a 2.9 minutes difference. It is nothing. Statistically, it is nothing. Same. Yeah, simply we just buy the cheaper one. Yeah, it's the same. It's a statistically, significantly, it's the same. So can you make the conclusion? I'm sorry. Can you make the conclusion and interpretation? Right? Yeah.
So when we're trying to find things that are, so obviously the know that they are the same, and the alternate is that they aren't the same. If the alternate is that we're trying to find if they're not the same, is it two-tailed?
Because it asks us, there's no difference. But that was the claim.
Right, and that's what makes it two-tailed, right?
Yeah.
Is there any other factor in which it would make it two-tailed?
Another factor?
Yeah.
It's maybe difference, or even no difference, or even sometimes they want to check change. Simply change means is it getting bigger or smaller, is either way, right? The change, or sometimes if it is not clear, getting smaller, getting bigger, not clear, and simply we just state the truth. Yeah.
We think that if we always use like on the HO equality.
Yes, always is equal in the mall.
Other options either before or after.
The other one we have 3 options: less than, greater than, or not equal to. But in this example, it's clearly it asks us if they are different or not, right? It's clear.
But if it's clear, then it's less.
Sometimes if the brand B is faster, if that was the claim, then this one must be smaller, right? It's a smaller. Smaller means faster, right? Yeah. So this like this way. Writing, right? Yeah. Probably nobody wants to test if the brand A is better. Yeah. See, on average, brand A takes longer, right? Yeah. So nobody wants to test it's less than, right? Yes.
So the p-value was less than alpha, would it be with rejection?
Yeah, absolutely. Because you know what was the definition of the p-value? You know the definition of the p-value was probability the possible H0 is true. Now in this example, how much is the probability? It's bigger than 25%. Like as the chance of the rain. Chance of the rain tomorrow between 25%, 50%. Yeah, simply we can expect rain tomorrow, right? We cannot deny or we cannot say no rain tomorrow because the chance of rain between 25% and 50%. That is the same. If the chance is lower, it's only 10%, 5%, yeah, nobody expect the rain tomorrow. Reject HO. So it is the independent two-sample t-test, comparing the means. Good, right? And the last one, proportion. Yeah, it's a comparing two proportions. Yeah, it is the last topic. Yes, we're done. We are going to done. Absolutely, we have 2 groups and the same sample size, right? Yeah, they don't have to because still we have independent 2 groups, but 625 and 625 as a totally the sample size is 1250. It's all together. It's a 1250. And what is this one? The county clerk. Improve, they want to improve the registration, right? So one group is no remind. Yeah, they didn't remind the people, right? But group 2 is remind them. Is remind them for the registration. So we have 295, and here's the 350. Absolutely, yeah. When they remind, there is a more the registration, but we want to test if it is really more, right? And 5%. At 5%, we want to test if greater in the second group. Is greater in the second group. Absolutely, it will not be two things, right? So we have to choose left one or the right one, right? But it does not have the mean and it does not have the standard deviation either. So it's absolutely the null hypothesis. We have to compare the two proportions. And alternative hypothesis, greater, less than, which one? Who must be greater? P2. The second one must be greater, like this way, right? Less than. It is left tail. Good, right? So let me take the two proportions. P1 head is 295 out of 625. And the second proportion is 350 out of the same sample size, 265. Yeah, absolutely. The second proportion is bigger, but we want to test if it is really bigger. So let me take the two proportions, 295 over 625. I have a 0.472, and the second one, 0.5 and 6. We have two proportions, right? We are going to compare. What do you expect? Do we have a z-score or t-score? Z-score. Always before for proportion or proportions, always the z, right? So we are going to take the test statistic, the z. Absolutely, we have to take the proportion difference, P1 head minus P2 head. Denominator will be square root. You know, always we can modify the confidence interval to get the test statistic. So do you remember what was the square root? Let me show you. Let me show you the square root in chapter 7. Yeah, I opened the chapter 7. Let me get down for the last one. Yeah, here was the confidence interval for the proportion difference. And here was the square root. Inside of the square root, we plug the P1 head, P2 head, Q1, Q2, right? Yeah. I'm sorry, we are not going to use this.
Oh, okay.
We take another proportion. We will take another proportion. It will be P bar. Do you remember who was the bar for? Sample mean average. We need the third proportion average. How? Just to take the sum. Just to take the sum of 295 and 350, the two denominators, I'm sorry, the two numerators, And separately, we take another sum, the denominators, 625 and 625. Then the sum of the two numerators will be 295 and 350. It will be 645. And the total sample size was 1250. So the fraction, the third one, the mean of the proportion will be 645 over 1250. I have a 0.516. We are going to use the P1 pad and P2 pad. We are going to all of them. Yeah, we are going to use the three proportions to get the test statistics.
So
But
the next one gonna be Q bar?
Oh, yes, absolutely. Absolutely. Yeah, we are going to plug the P bar, Q bar over N1. P bar, Q bar again over N2.
If I did 0.472 plus 0.56 divided by 2, will it be the same?
Say again?
If I did 0.472 plus 0.56
No,
divided by 2.
You can try. You can just add up 0.472 and 0.56 divided by 2. Probably you will get exactly same average. You know why? Because we have a same sample size. But now we have an independent two sample. They don't have to be same. When we have a different sample size, the denominator is not the common denominator. That is not true, right? So always we take the sum, and we take the other sum and take the fraction, right? It is the correct way. That don't try it, right? But now here is good because the common denominator.
And this works for independent and dependent variables?
We didn't try the proportion difference for the dependent variable. The dependent variable, the paired data, we simply apply the t-test. You know, the t-test only for the mean, not the proportion. For the proportions, always we use the z-score, right?
The proportions
So-
are always gonna be dependent, independent.
Say again?
Proportions are always
Yes,
gonna be independent.
yes. You know, absolutely. Sometimes we have dependent variable for two proportions, but I didn't give you any example. Yeah, absolutely. In actual field, we might have the dependent sample for proportion. Ignore it. It's too much. It's too much, right? Yeah, I gave you only the dependent variable for the means, right? And we use the t-test, right? Yeah, it's just a focus on that.
Like if you were analyzing two groups, female, male, but then on the female you had sisters. So
Ignore it. I don't want to tell you. Yeah, there's no. As a no dependent sample for proportion. Please. No. Yeah. Only the dependent sample, dependent pair sample, only for the mean, right? Yeah. But yeah. Anyway. Yeah. Yes, what?
So we won't have any dependent samples for proportions of
No.
categories
No.
or,
No. Not at all.
No, I'm not on homework either.
Not here. No. If we want, take STEM minor. Okay. It's advanced statistics. Yeah. We might discuss the other examples. No, not here. See, can you compare the three proportions? It is a smaller one. It is a bigger one. And now the average. Where is the average? Always in the middle. You know why? Because it is an average. It is the average. It's between P1 and P2. Always inside between these two. The reason why we plug the P bar, because always, it's not only here, always we got the test statistic from the null hypothesis. Let me show you the one sample z-test, the very first one. Let me show you the very first one. Yes, look at this. We got the test statistic using the mu0. Do you remember where did we get the mu0? The mu0 was from the null hypothesis. Step number 1, we stated the null hypothesis. Unknown population mean was equal to mu0. We use the initial setting value in the null to get the test statistic because we assumed the null is true. Unknown population mean was equal to mu0. We set up initially mu0. Based on the null hypothesis, we got the test statistic, and then we found the p-value from the z-table, and also we made conclusion. Here is the reason why we have two types of the conclusion: reject the null or not to reject the null. Because every single step, step 3 p-value, 4 conclusion, under the null hypothesis, right? So let me go back to the proportions. Yep, here. Under the null hypothesis, what is stated? They are same. We assume they are same. They are same. So we merge two independent samples together and we take the average, right? So that is the reason. So we plug the average, P bar, Q bar, and P bar, Q bar again. But in chapter 7, when we made the confidence interval, we plug P1 hat, P2 hat. You know why? Because we didn't state HO. Simply we just estimated the interval estimation, right? We didn't state the null hypothesis. We didn't assume they are same. But in chapter 8, in step number 1, in the null hypothesis, we assumed they are same. So because of that, we take the average and plug into the inside of the denominator, square root. Then we take the test. So for the proportions, it's a little bit different. Yeah, be careful. So let me plug into the formula. Now it must be 0.472 minus 0.56. And then 0.516 times is 0.484 divided by 625. And the second one would be same. 0.516 times is 0.484 divided by the other sample size, but they are same. Is it good, right? Then now let me take the proportion difference. 0.472 minus 0.56. Then I have negative 0.088. And let me take the square root of 0.516, 5484 over 625. You know, in this case, they had same sample size. So this one and this one will be same. And simply I just take twice, right? Then the denominator would be 0.02827. Then now the fraction, the test statistic, is a negative 0.88 over 0.02827. You know, it is a z-score. Yeah, always we needed 2 decimal places for the z-score. So let me take a negative 3.1. That will be the test statistic for comparing the proportion difference. Now step 3, I need the p-value from the z-table. From the z mean equals 0, negative 3.1. Can you give me the probability from the z-table at negative 3.1? 0.0009. Thank you. 0.0009. Do I have to do 1 minus? Why? Why not? We needed left table. Z-table always give us the left table, right? Yeah. Should I take twice? Twice only for the 2 table. Less than it is the p-value. Yes, it is the p-value here. P-value. How much was the alpha? Did you see it, alpha? Alpha was 5%. Now the p-value 0.0009 from the left table less than alpha. What will be the conclusion? Reject the null. The conclusion will be reject the null. I have to interpret alternative hypothesis, H1. What is that? Proportion number 1 is smaller than proportion number 2. Group 2 has bigger. What was group 2? Reminded them. It worked. It worked. When they remind the voters, they registered more. It worked. So that will be the interpretation. Okay, I finished. Yeah. Thank you. Taking statistics, right? Yeah. I told you, 1 more week, we are going to review Monday, Wednesday, Friday. And the next Monday, we are going to take the last exam, the final. Okay. After class, immediately, I will email you the summary from chapter 7 and 8. And one day I told you, you can bring my summary and Z-table, T-tables, and you can prepare your summary, handwritten, with as many pages you want, right? Yeah. So next week, we are going to review. Okay. And now here is the quiz number 25. It is 2 proportion z-test. It is the 2 proportion z-test. See, they want to test a difference. So the step number 1 must be comparing 2 proportions. And we have to state P1 is not equal to P2. And you have to take 3 proportions, P1 hat, P2 hat, second one, and also you have to take the merged one. The merged one, yeah, is the average. And the test statistic will be P1 hat minus P2 hat, P bar, Q bar over N1, P bar, Q bar over N2. right? Yeah. Oh, this is a 23.
This is 25.
Huh?
It's 25.
Yeah, it is quiz number 25.
And from keyboard, if not to be something special.
1 minus p bar will be q bar. Yes, always the q from 1 minus the p. And the q is another probability, so it must be positive and less than 1, 2. Let me see. 60 over 225 and 59 over 195 and 60, 59 over 225 and 195. Oh my God. Just a second, I'm sorry. Yes. 195 and 60 over 225. You know, when you are doing the homework, please using is more than 3 decimal places, but in the quiz exam, let me take the 2 decimal places. So it is the 0.27, and the second one, 0.30. Am I right? Thank you. And then let me see. Point 28. Did you get 0.28 forward? Yeah. Then the Q must be 0.72 over 225. And the second one, same, 28, 72 over 195. Then now the proportion difference will be negative 0.3 28. Point 0439. Am I right? I have no idea. And the z-score, the test statistic, I have 0.0439. Negative two decimals, negative 0.68 I have. Anybody who got negative 0.68? Did you get 68? Thank you. Anybody else? How much is yours? 82? Negative 0.82? You know, because of the rounding problem, right? I'm using only the two decimal places, so I got negative 0.68, but you got negative 0.82. It doesn't matter. But when you are doing the homework, more decimal places, at least 3, please, at least 3, right? But now it doesn't matter, right? Yeah. So I got negative 0.68, and some of you get negative 0.8. What did you say? 82? Well, probably some of you got negative 0.70 something, right? Everything is good. Yeah, because of the rounding. Yeah. But anyhow, we need the probability. See, we stated two-tailed, right? Oops. Two-tailed. So let me take the probability.
Isn't that a big difference though, 0.68?
Yeah, it's possible. It is possible. Yes. Yeah. We don't care. Yeah, it's fine. I can take care of it. Don't worry about that. Then now from the Z table, and we got, it's negative 0.68. So let me take the probability. It's negative 0.68. My probability is less than 0.6 and 8. I have 0.2483 at negative 0.68. How do you think? Is the p-value? What should I do then? Multiply 2 twice, because we stated it's a two-tailed. Oh my god. 0.2483 times 2. My p-value will be 0.4966. Probably your p-value is much bigger. It's much bigger than here, 5%. So we cannot reject the null hypothesis, right? Yeah. So any other test statistic, any other p-value, we do not. Step 4, not to reject HO. We have to interpret HO, right? What was this for? You know, we compared men and women. We compared the men and women. No difference. It's no difference because we didn't reject the null hypothesis. No difference. Have a nice weekend. See you on next Monday. We are going to review.